Starfarers by Poul. Prologue. Look yonder. The man pointed northeast and aloft. That very bright star in the Milky Way. Do you know it? Yes, answered his son. Alpha Centauri, the nearest to us. It's two, really, and a third that is dim. Don Lucas Nansen Ochoa nodded, pleased. Juan was barely past his 7th birthday. Now look up from it, a little to your right. That other brilliant one is Beta Centauri. Is it close, too? No. It's far off. Almost 70 times as far, I have read. But it shines thousands of times as bright as our sun. Most of those we see are giants. Else our eyes could not find them across their distances. Man and boy sat their horses for a while in silence. They had drawn rein after leaving well behind them the house and its outbuildings, walled off by a cedar grove. The autumn air rested cool, still, and altogether clear. They had light enough without a moon, stars crowding heaven, galactic belt gleaming frosty. The Paraguayan plain rolled away through this dusk toward darkness, grassland broken by strands of trees and big, stump-shaped anthills. No cattle were in view, but now and then a lowering went mournfully through the early night. "Where are they?" whispered the boy at last. Awe shivered in his words. Don Lucas's hand traced an arc along the constellation. Look on upward from Beta, to your left. Epsilon. Do you see it? And past it, Zeta. The name Zeta means it's the 6th brightest in the Centaur. That's where the signs are. At Zeta? No. As nearly as I can find out from the news. That star just happens to be in our line of sight to the things. They're actually far beyond it. Are they coming here? Nobody knows. But none of them are headed straight toward us. And we don't know what they are. Natural or artificial or what. All the astronomers can say is that there are fiery points of X-rays moving very fast, very far away. The news programs yammer about an alien civilization, but really, it's too soon for anyone to tell. Don Lucas laughed a bit. Least of all, an old estanciero like me. I'm sorry. You asked me to explain what's been on the television, and I cannot say much more than you must be patient. Juan pounced. Are you... I hope they'll corral the truth while I'm still above ground, but you should surely live to hear it. What do you think? Don Lucas straightened in the saddle. Juan saw his face shadowed by the wide-brimmed hat, like a pair of wings against the sky. I may be wrong, of course, he said. Yet I dare hope someone is faring from star to star, and someday men will. Suddenly, overwhelmed, cold lightnings a-flicker in him, The boy stared past his father, outward and outward. It was as if he felt the planet whirling beneath him, about to cast him off into endless space, and his spirit rejoiced. He became the grandfather of Ricardo Nansen Aguilar. With never a sight of beautiful, changeable earth, Farside gained a night which stars made into no more than a setting for their brilliance, and the lunar bulk shielded it from the radio noise of the mother world, and the stable mass underfoot and the near vacuum overhead were likewise ideal for many kinds of science. It was no wonder that some of the most gifted people alive were gathered here, in spite of monastic quarters and minimal amenities. Besides, Muramoto thought, those should improve. Already, the desolation of stone and dust was redeemed by an austere elegance of domes, detectors, dishes, taut and silvery power lines. As his car neared observatory headquarters, he glanced through its bubble top and found the red beacon light that was Mars. People there too nowadays. An old thrill tingled. Yes, but man... yes, man does not live by bread alone, nor by economics and politics. It was the vision of ships flying through heaven that got us back into space in earnest. Damn it, this time we'll stay and keep going. He reached the topside turret, linked airlocks, crossed over and descended. The corridor below felt doubly drab by contrast. However, he could move fast along it, enjoying the long, low-gravity lope. Ordinarily, an officer of the United States Aerospace Force was expected to be more formal. He had called ahead. The director awaited him in her office. She greeted him a little warily, offered him a chair, told the outer door to close, and sat down again behind her desk. For a few moments, they exchanged ritual courtesies. How were things going here? How were things going back home? How had his flight from Earth been? And his drive from Port Apollo? Then Helen Lewis leaned forward and said, "Well, I'm sure your time is as valuable as mine, Colonel. Shall we get directly to business? Why have you requested this meeting? And why did you want it to be confidential?" He knew she shared the distaste for the military that had been common among intellectuals, at least since the Siberian action. His best approach was straightforwardness. "You seem to prefer it that way, Dr. Lewis. May I be frank? You've entered a request for a large expansion of your facilities. The wide-orbit interferometric metric system, especially, would count as high-priced even in free and easy times, and you know how tight budgets are at present. I'm afraid a wish list of research projects won't open any purses soon. After all, you're still discovering marvelous things with the equipment on hand. What do you really want to search for?" Her gaze challenged his. Why does your service want to know?" "Because we've gotten hints that this may be something we'd go for, too. Muramoto lifted his palm. No, please, not with any idea of warlike application. If our guess is right, it is an area that concerns us strongly. But we are not just a few men and women in uniform. We include civilians, scientists, and certain members of the President's Advisory Council. She flushed beneath the gray hair. A fist clenched. My God, does that clique decide everything these days? Muramoto had his own wistfulness about the Republic that Jefferson helped found, but it wasn't relevant today. Myself, I hope your request will be approved. Yes, and I'd like it to be an international undertaking, as you've proposed. So would my superiors partly to save American money, partly on principle. We aren't blind chauvinists. Taken aback, she sat quiet for a while before she murmured, I presume not. But you haven't given us reasons to fight for what you want, he said. If you'll tell me what you have in mind and why it shouldn't be publicized, he smiled, you'll find we military are pretty good at keeping our mouths shut. Lewis reached a decision. She actually returned his smile. The truth is nothing desperate. It's bound to come out in due course, and certainly should. But the potential for sensationalism, she drew breath. You see, our latest observations lie at the limits of sensitivity available to us at present. They could be in error. An announcement followed by a retraction would do worse than wreck several careers. It would harm this whole institution. I see. I thought so, he replied, intently. You think you have found more starship trails, don't you? She nodded. Although he was not surprised, his mind whirled back through time, 27 years, and again he was a boy, watching the news, listening to the discussions, feeling the dream explode into reality. Point-like sources of hard X-rays with radio tails crisscrossing a region in the Centaur. Some have come suddenly into being as we watched. Others had blanked out. Parallax measurements taken across interplanetary spans show they are 5,000 light-years distant. Therefore, maximum transverse motion joins with Doppler effect to show they are traveling at virtually the speed of light. What can they be but the trails of material objects blasting through the interstellar medium? Slowly, grudgingly, more and more physicists admit that the least fantastic hypothesis is that they indicate spacecraft. They aren't many, less than 100, and they seemed confined to a volume of perhaps 200 parsecs diameter. Why that is, why they don't range everywhere, why they haven't come to us, those are among the mysteries. But all at once, humans around the whole Earth want us also to be in space. Through a quickening pulse beat, he heard Lewis's careful, dry voice. Lately here, using the Maxwell superconducting telescope, we found what appear to be similar phenomena elsewhere. The traces are faint, scattered, from sources far more distant than those behind Zeta Centauri. They are few, and none is as rich in objects as that region is. But there they are, or so we think. To confirm, we need better instruments that will also let us pinpoint them in the galaxy. More important, new theoretical work suggests that improved data will give clues to what the power source is. There's this great stumbling block, you know. Where does the energy come from? I honestly believe we're on the verge of a revolution in our understanding of the universe. I can show you around, introduce you to the people doing the research, let you judge for yourself before you report to your group. Would you like that? I would, he answered inadequately. And no promises, you realize, but I expect you'll get what you want. It happened that Avery Houghton launched his coup on the day that Edward Oliveris recorded the television interview. Nothing had overtly begun when the physicist reached his office, but the crisis had been building up for weeks. Demands, threats, demonstrations, riots, and was now unmistakably close to the breaking point. Most Americans who could stay at home huddled over the newscasts. The amber-hued Hispanic facades of Caltech stood on a nearly deserted campus, impossibly sunlit and peaceful, while fighter jets drew contrails across the blue above them. Oliveris was stubborn about keeping promises. He arrived at the appointed hour. The camera crew was already on hand, trying hard not to act nervous. Joanne Fleury succeeded in it. She had her own professional pride. I fear we won't draw much of an audience, Oliveris remarked while the crew was setting up. Maybe not for the first showing, Fleury said. Though I imagine a fair number will tune in around the world, regardless of our troubles here. But the rebroadcast will pull their billions. We could postpone. No, if you please, sir, this is going to be a classic in science journalism. Let's do it while we've got the chance. Planning and the sketchy run-through had gone before, and the business went more smoothly than might have been awaited. But then it offered a brief escape from what was outside. After the cameras had scanned the book-lined room, the battered desk, the portrait of Einstein, while Fleury gave her introduction. Scientist, mathematical physicist, as famous as he is modest, we'll discuss his latest and greatest achievement. They moved in on her and him, seated in swivel chairs. A projector spread a representation of the galaxy behind them. Ruddy nucleus and outcurving blue-tinged spiral arms. Awesome athwart blackness. Somehow, his slight frame belonged in front of it. She gestured at the grandeur. Alien spacecraft traveling there, almost at the speed of light, she said. Incredible. Perhaps you, Dr. Oliveris, can explain to us why it took so long to convince so many experts that this must be the true explanation. Well, he replied, if the X-ray sources are material objects, the radiation is due to their passage through the gas in interstellar space. That's an extremely thin gas, a hard vacuum by our standards here on Earth. But when you move close to C, we call the velocity of impeded light c, then you slam into a lot of atoms every second. This energizes them, and they give back the energy in the form of hard X-rays. For a minute, an animated diagram replaced the galaxy. Electrons tore free of atoms, fell back, spat quanta. The star images returned as Oliveris finished. To produce the level of radiation that our instruments measure, those masses must be enormous. Mostly due to the speed itself, am I right? Fleury prompted. Oliveris nodded. Yes. Energy and mass are equivalent. As a body approaches c, its kinetic energy, therefore its mass, increases without limit. Only such particles as photons, which have no rest mass, can actually travel at that velocity. For any material object, the energy required to reach c would be infinite. This is one reason why nothing can move faster than light. The objects, the ships that we're talking about, are moving close to c, that their masses must have increased by a factor of hundreds. Calculating backward, we work out that their rest masses, the masses they have at ordinary speeds, must amount to tens of thousands of tons. In traditional physics, this means that to boost every such vessel, you would have to annihilate millions of tons of matter, in an equal amount to slow down at journey's end. That's conversion on an astrophysical scale. Scarcely sounds practical, eh? Besides, it should produce a torrent of neutrinos, but we have no signs of any. Fleury picked up her cue. Also, wouldn't the radiation kill everybody aboard? And if you hit a speck of dust, wouldn't that be like a nuclear warhead exploding? A jet snarled low above the roof. Thunder boomed through the building. Cameras shivered in men's hands. Fleury tensed. The noise passed, and she found herself wondering whether or not to edit this moment out of the tapes. "Go on, please," she urged. Oliveris had glanced at the galaxy and thence at Einstein. They seemed to calm him. Yes, he told the world. There would have to be some kind of, I'm tempted to say, streamlining. The new spaceborne instruments have shown that this is indeed the case. Gas and dust are diverted so that they do not encounter the object itself, but flow smoothly past it at a considerable distance. An animation represented the currents. The ship was a bare sketch. Nobody knew what something made by non-humans looked like. This can, in principle, be done by means of what we call magnetohydrodynamics. Fleury had regained her smile. A word nearly as naughty as the problem. It takes very powerful force fields, Oliveris said. Again, we meet the question of energy. Of course, the requirement is minuscule compared to what's necessary for the speed. And nobody could build a nuclear power plant to supply that. No. If you did, you'd find you had built a star. Then where does the energy come from? The original suggestion was that it comes from the vacuum. Could you explain that? It sounds like, well, Alice's Cheshire cat. Oliveris shrugged. A good deal of quantum mechanics does. Let me try. Space is not a passive framework for events to happen in. It is a sea of virtual particles. They constantly go in and out of existence according to the uncertainty principle. But the energy density implied is tremendous. But we don't know how to put the vacuum to work, do we? Only very slightly, as in the Casimir effect. You see, the more energy you borrow from the vacuum, the shorter time before it must be returned. Both these quantities, energy and time, are far too small to power a spacecraft. But now you, Dr. Oliveris, have shown how it can be done, Fleury said softly. He shook his head. Not by myself. I simply pursued some speculations that go back to the last century, and then the new information started to come in from the new instruments. Fleury gestured. The galaxy gave way to the observatory on lunar far side. After a few seconds, the scene swept across millions of kilometers to the devices in their huge orbits. Representations of laser beams quivered between them and back toward the moon, bearing data. An antenna pointed at a constellation. Briefly, the outlines of a centaur stood limned amidst those stars. It vanished, and a telescopic view expanded. It zoomed past a globular cluster of suns, on toward the one called Zeta, and on beyond. Tiny fireballs twinkled into existence, crawled across the deep, and died back down into the darkness, while fresh ones appeared. The bow waves of the Agroses, Fleury intoned. The animations ended. The galaxy came back. Details we could not detect before, such as certain faint spectral lines, are now lending confirmation to my cosmodynamic model, Olivares said. And that model, in turn, suggests the energy source for such spacecraft. That's all, he ended diffidently. I'd say that's plenty, sir, the journalist responded. Could you tell us something about your ideas? It's rather technical, I fear. Let's be brave, please. Say whatever you can without equations. Olivares leaned back and drew breath. Well, cosmologists have agreed for a long time that the universe originated as a quantum fluctuation in the seething sea of the vacuum, a random concentration of energy so great that it expanded explosively. Out of this condensed the first particles, and from them evolved atoms, stars, planets, and living creatures. Excitement throbbed beneath the academic phrases. At first, the cosmologist took for granted that beginning involved a fall to the ground state, somewhat like the transition of an electron in a high orbit to the lowest orbit it can occupy. But what if this is not the case? What if the fall is only part way? Then a reservoir of potential energy remains. For an electron, it's a photon's worth. For a universe, it is vast beyond comprehension. I've shown that if the cosmos is in fact in such a metastable condition, we can account for what the astronomers have observed, as well as several other things that were puzzling us. It's possible to tap energy from the expended substrate. Energy more than sufficient for lengths of time counted not in Planck's units, but in minutes, even hours. Fleury whistled. How can we do this? Olivares chuckled. I'll leave that to the laboratory physicist, and afterward the engineers. In principle, though, it must be by means of what I'll call a quantum field gate. We can use a Bose-Einstein condensate to generate a certain laser-like effect and bring all the atoms into two parallel superconducting plates into the same quantum state. The consequences are nonlinear and result in the creation of a singularity. Through this, the energy of the substrate flows. Presumably, it will distribute itself evenly through any connected matter, so that the acceleration is not felt. Ooh, you're right. This is kind of technical. A touch of practicality should liven it. How does the pilot get the ship headed the way it wants to go? A good question. Olivares approved. I'm glad you know the difference between a scalar and a vector. I think the velocity vector must increase or decrease linearly. In other words, when the ship acquires the new energy, she continues in the same straight line direction as she was moving in. I'm still working on the problem of angular momentum. More technicalities, Fleury said ruefully. You mentioned having this energy for a period of maybe hours. Must it then go back? Olivares nodded. Yes, just as with the familiar vacuum, a loan from the substrate must be repaid. The product of energy borrowed and time for the loan is a constant. However, with the substrate, the constant is immensely larger, a multiple of the Planck energy, which is itself enormous. The quantum field collapses, reclaiming the borrowed energy for the substrate. But the ship can take out another loan right away. Evidently, the instruments have, in fact, detected flickerings in the X-ray outputs that correspond quite nicely to this. From the inverse proportionality of the energy and time, it follows that every jump is of the same length. My preliminary calculations suggest that this length is on the order of 100 astronomical units. The exact value depends on the local metric. Olivares laughed. Never mind. Maybe we can talk a little about what a voyage would feel like aboard a ship like that, Fleury proposed. Why not? It'll take us back to the less exotic territory. Could you review the basic facts? For some of us, our physics have gotten kind of rusty. It's simple enough, Olivares said, quite sincerely. When you travel at relativistic speeds, you experience relativistic effects. I've mentioned the increase of mass. The shortening of length in the direction of motion is another. Of course, you yourself wouldn't notice this. To you, the outside universe has shrunken and grown more massive, and your observations are as valid as anybody else's. What about the effect on time? I should think that matter most to the crew. Yes, time dilation. Loosely speaking, if you're traveling at close to sea, for you time passes more slowly than it does for the friends you left behind you. One of those spacecraft may take several hundred years to cross the several hundred light years between her home port and her destination. To those abroad, whoever or whatever they are, a few weeks will have passed. Before she could head him off, but it could be edited out later if need be, Olivares continued. The new theory modifies this a bit. If you travel by way of the quantum field gate, you never get the full time dilation you would if you accelerated to the same velocity by ordinary impossible rocket means. However, at high energies, the difference becomes too small to be worth thinking about. Contrastingly, the less energy you borrow from the substrate, the worse the ratio is. You could take an extremely long time, by your clocks, theoretically forever, to transit the fixed distance of a jump at an ordinary speed. You'd do better to use a regular jet motor. So the quantum field gate is not for travel between the planets, nor do I expect it to serve any other mundane purpose. But it will take us to the stars, Fleury breathed. She guided the conversation from that point, retracing much ground, expanding explanations, weaving in a few personal human matters. It would be a raw material for a program that should awaken eagerness in every thinking person who saw it around Earth on the moon and Mars, faring to the ends of the solar system. At last, the two stood up. She shook his frail hand and said, Thank you, Dr. Oliveros, for this hour, which had actually been almost 3. And thank you infinitely more for everything you have given the human race. That would remain in the tapes. Immediacy closed in. Blasphemous though it felt, she could not help herself. She went to the television set in his office and tuned in a newscast. Terror leaped from the screen. Houghton's junta had seized the Capitol and White House. He had declared a state of emergency and martial law. A number of military units here and there across the country had mobilized to resist, and battle had erupted at several locations. She saw combat in the air above Seattle, street fighting in Houston, a city block burning in Minneapolis. She turned and seized Olivares' hand again. Through her own tears, she saw his. "No, God damn it," she cried. "We've got work to do. You and I." Conflict sputtered out in the next few days as Houghton prevailed. After all, he and his cause were widely popular. He was now the permanent chief advisor to any and every president of the United States. The trial and execution of his predecessor assured the docility of Congress and the courts. His reign lasted until his death, 19 years later. Olivares lived much longer in history. Once an aspect of nature is known, quantum computers and nanotechnic construction make for rapid progress. Barely 10 years pass between the publication of his theory and the departure of the first spacecraft for Alpha Centauri. Surely, billions of eyes watched on screens as if left Earth orbit. A few persons on Himalaya were luckier. That little moon of Jupiter chanced to be near when the vessel passed by. For many hours before and after the moment, work ceased. Almost everyone crammed into the habitation domes from which it would be directly visible. Dmitry Sumarokov and Karl Vogel did not leave their station. They and the robots were prospecting the Stefanos crater area. It might have been more exciting to watch with the group, but would certainly have been more uncomfortable. The partners simply donned spacesuits, took what optical gear they had, and went out of their round hut. Low above a toppingly near horizon, the giant planet loomed close to fullness. Larger in the sky than Luna and Earth's, Lion Tawny, banded with clouds and swirled with storms and subtle hues, a glimmer of rings offside. It flooded most stars out of vision. The radiance fell soft over ice, rocky upthrusts, scars and pockmarks. Breath and pulse beats sounded loud in the silence. Trouble with the air recycler had caused a delay. Repairs couldn't wait. Dead men can't watch anything. With scant time to set up, they wasted none in speech, except for an occasional muttered curse. But when they had their telescope aimed and an image appeared in the display, Sumarakov whooped. "There! See, Carl, see?" A point of light swelled rapidly within the frame. It turned into a jumble of glints and shadows. It became a bright spheroid, from which reached structure that seemed as fragile as spiderwebs. The telescope swung, tracking. Vogel peered along it. Pointing, he said, his tone not quite steady, "Selb das Schiff." In English they shared, "Someday our children will envy us, Dmitri." The naked eye saw a spark flit above a crag and across the night. It could have been any satellite, catching the rays of the sunken sun. 2 Galilean moons outshone it. But Sumarakov and Vogel stood enthralled. It faded, dwindling away into the distance. Their gaze went back to the display. Abruptly, the magnified image vanished in a flare. They glimpsed the reality as a wink near the Jovian disk. "What was that?" Sumarakov exclaimed. "The jet fired," Vogel answered. He had studied the subject more closely than the other man. "Approach maneuver." "So soon?" "You would not want to operate a plasma jet in Jupiter's radiation belt." No, certainly not." Again, the shape was in telescopic view, coasting along on gravity and momentum, shrinking. "The day will come," Sumarakov said raptly, "when none of this will be necessary." I don't know," Vogel replied. Those robots, they do have to be well away from the sun before they turn on the 00 drive. Something about space not being too warped. Sumarakov blinked at him. 00? That is what they are lately calling the quantum field gate drive. Have you not heard? A ship springs from the energy state normal in this universe, what they call the 0 level, to the super high energy level it gets from below the universe, and then falls back down again to normal over and over. I see. First, they may as well save fuel by letting Jupiter pull them out of the ecliptic plane and aim them at the goal. Vogel spoke absently, his attention on the image. Soon, it would be invisibly small. Yes, I know that, Sumarakov said. Everybody does. Enthusiasm thrust irritation aside. I mean, the technology will improve. Jets will be screened, fuel will be less important, and it will be humans, not machines, who go to the stars. If machines do become as intelligent as humans, or more so. That will never happen. I know some neuropsychology, consciousness, creative thought. That is not merely a business of electrons and circuits. It is something the entire living human organism does. Well, maybe. But all of us here would be in a bad way without our robots. Talk broke off. Both men were watching the starcraft too hungry. When it was gone from them, they went back inside, and presently back to work, as if awakened from a dream. Yet the work had its fascination, establishing a settlement in the Jovian system, coordinated with the outpost on the asteroids, steps in the industrialization of space, until the wealth of the planets showed to Mother Earth and humans need no longer maim and defile her. Such was the hope of the far-seeing. The hope of the most people concerned in the endeavor was to make a profit. And this was right and necessary. No civilization, whatever its social and economical arrangements, can continue forever throwing resources into a void. It must eventually start to reap some kind of material return. 8.5 years after the spacecraft left Sol, its first laser-borne messages arrived from Alpha Centauri. What they revealed was wonderful. 3 years later, transmissions ended. The unforeseen abilities of navigating among rock swarms between two suns had overwhelmed the computers. The vessel perished in a collision. Its wreckage became another small heavenly body. By then, however, the first ships designed to carry human crews were taking their first flights.